previous class, that is trigonometric functions is the name of the topic. Trigonometric function. This is actually chapter 3, class 11. Fine. In the previous chapter, in the previous classes, we have talked about the trigonometric ratios, their signs in different quadrants, and how to find the value of the trigonometric angles in different quadrants. Fine. Today we shall talk about trigonometric functions of sum and difference of two angles. Trigonometric functions of sum and difference of two angles. And this is nothing but this we call as compound angles. They are compound angles. When we add or subtract two angles, that angle is compound angles. And when we multiply any angle by a real number, it is a multiple angle. Fine. So we will be discussing about multiple angles also if the time permits. Otherwise, in the next session, we will talk. Now, before few points which we have already discussed earlier, that is sine of minus x is minus sine x and cos of minus x is cos x. I'm sure you remember this because just consider, just for the sake of your memory, once again I refresh it. This is an angle x. Then sine is opposite by hypotenuse, right? But what is minus x? Minus x is when this line moves in clockwise direction. That is, if it comes this way, then this angle is minus x. And the opposite side, that is the perpendicular, this is negative of y. Along this y axis, this is minus y. And this is same. So this becomes minus of sine x. Fine. In case of cos, cos is adjacent by hypotenuse. So whether the angle is this side or this side, this adjacent is not changing. Neither the hypotenuse is changing. So it remains positive cos. Fine. So this is actually the basic part of it. We will have to bear it in mind. Now let us call it that first and second. Now third important formula is say cos x plus y is cos x cos y minus sin x and sin y. This is a formula. X plus y, this is a compound angle, right? And this is its expansion. And similarly, if in case this is minus, cos of x minus y is cos x cos y plus, in case of minus, here it comes plus sin x sin y, right? Now immediately with this information, in this, suppose I write this cos pi by 2 minus x. What I did, I replaced x by pi by 2 and y by x. So according to this formula, this becomes cos pi by 2 cos x plus sin pi by 2 and sin x. Okay. Now cos pi by 2 is 0. So this part becomes 0 and sin pi by 2 is 1. 1 times sin x is sin x. Okay. So we arrive at a very important result that cos pi by 2 minus x is sin x. This is a very important result. We are supposed to know it. And similarly, if I work with sin pi by 2 minus x, I can write it as, taking the help of this, I will write it as cos of pi by 2 minus pi by 2 minus x. This has come right from this result. I am putting this in terms of this result, right? And if we solve this, we get cos pi by 2 minus pi by 2 plus x. Pi by 2, pi by 2 cancels and we are left with cos x. So here is another important result. Sine of pi by 2 minus x is cos x. Fine. Hope till here I am clear, right? Now the next important identities. Now see, this is actually along with this, we just happen to discuss this. Now next formula is sine x plus y is equal to sin x cos y plus cos x sin y, and sine of x minus y is sin x cos y minus cos x sin y. It is simple, minus may minus, and in case of plus it is plus. Okay. Now again with this, if we consider cos of pi by 2 plus x is minus sin x. Sin pi by 2 plus x is cos x. Cos pi minus x is minus cos x, and sin pi minus x is sin x. As in the above case, we can work out these also on the same lines, right? Now the next important relation in this continuation is 7th, that is tan of x plus y is equal to tan x plus tan y upon 1 minus tan x tan y. Don't worry, you need not learn them by heart. Keep on practicing. Automatically, you will get into a habit of knowing them as you solve more and more problems. Now, in this case, if we have tan of x minus y, that is simple tan x tan y by 1 plus tan x tan y. Now see, in plus it is tan x plus y, and in denominator it is minus. In case of x minus y, it is tan x minus tan y. In denominator you have plus sign. Similarly, for cot, now this is cot of x plus y is cot x cot y minus 1 upon cot x plus cot y. Okay. Now here, actually this should be cot y plus cot x, but it makes no difference. But in case of minus, it will make difference. देखो, cot of x minus y is cot of x cot of y plus 1 upon cot y minus cot x. ये important है to be noticed because number of students commit mistake in this, and because of this they write cot x minus cot y, and because of this their problem goes wrong, right? Hello, hello. Yes. Now let us solve one example where we make use of these compound angles. Now see, we have seen compound angles: sine x plus y, cos x plus y, sine x minus y, cos x minus y, tan x plus y, tan x minus y, cot x plus y, and cot x minus y. So these are compound angles, and how they are used. Just see this example. Find the value of sine 15 degrees. Now, in order to do this, see, earlier we have learnt about the values sine 0, 30 degree, 45 degree, 60 degree, and 90 degree. Now you are asked to find out sine of 15 degrees. So solution, just pay attention. Now see, this sine of 15 degree can be written as sine 45 minus 30. Okay, or you can express this as sine of 60 minus 45, because 60 minus 45 is also 15, and 45 minus 30 is also 15. And why I have chosen 45, 30 and 60? Because these are the standard values whose values we know, we have learned in class 10 also, right? Now, using the identity sine x minus y, that is sine x minus y is sine x cos y minus cos x sine y. Put their values. Sine 45 is 1 by root 2. cos 30 is root 3 by 2. Cos 45 is again 1 by root 2. These the values you are supposed to know by heart. That will help you, because every time you can't go for calculating them. And sine 30 is half. Now take the LCM, which is 2 root 2. So here you have root 3, and this you have minus 1. Fine. This is the value of sine 15 degree. Fine. Hope you understood this. Let us take another example. Say example 2. Fine. Now in this question we have to find the value of tan 13 pi by 12. See, this type of questions we did in last session also, when we were discussing about the signs of the angles in different quadrants. Under that time, or in that session also, we solved these type of questions. Now see, this question can be solved. Tan 13 pi by 12 can be written as tan pi plus pi by 12, because pi plus pi by 12 is nothing but 13 pi by 12. And you know, this is the pi multiple, right? So this angle will become tan pi by 12. Now tan pi by 12 can further be expressed as tan pi by 4 minus pi by 6. Fine. 5 by 4, this is 6 minus 4, 2 by 24, that is 12. 12 is the LCM, 3 minus 2. Okay, this is also, or you can express it as tan pi by 3 minus pi by 4, because LCM is 12, 4 minus 3 is 1 by 12. Now after doing this, any expression you choose, then you can apply the form tan x plus y is equal to tan x plus tan y upon 1 minus tan x tan y. Clear? Suppose we take this value. Let me just try. Tan pi by 4 minus pi by 6. So we are to take the minus form. So this is minus, this will become plus. So I'll write it as tan pi by 4 minus tan pi by 6 upon 1 plus tan pi by 4 times tan pi by 6. Tan pi by 4 is tan 45, that is 1, minus tan 30. Tan 30 is 1 by root 3 upon 1 plus 1 times 1 by root 3. This becomes root 3 minus 1 upon root 3 plus 1, right? Further, this can be rationalized. I am here just trying to show you how the compound angles can be used. Now, if we take the other way, that is tan pi by 3 minus pi by 4. Again, same identity we are going to use, that is tan of pi by 3 minus tan of pi by 4 upon 1 plus tan pi by 3 times tan pi by 4. Fine. Now see, this is tan of 60. Tan of 60 is root 3 minus tan of 45 is 1. This is 1 plus root 3 times 1, that is root 3, which is again the same. So now the knowledge of compound angles give us more ways to break and find the values. Fine. This is what is all about compound angles. We shall be solving the questions from your exercise once we complete the discussion. Now, let me talk a bit about compound angles, which we will take up in the next session. Thank you very much for watching this. Stay healthy, stay happy till the next session. Keep watching. If you like this video, do subscribe and share it with your friends. Thank you very much. Bye bye for now.